Hello and welcome to this video for the 2022 Level 2 Math and Statistics paper, and for today we're going to look at the calculus standard. So let's get straight into it. So question 1, a function f is given by f of x equals to 2x to the power 4 plus 4x to the power 3 minus 20x squared minus 5. Use calculus to find the gradient of the graph of the function at the point where x equals to 3. So for this question, we're just going to differentiate to find the gradient function and then plug in the point x equals to 3. And we're just going to be doing that by using the power rule. And so f dash of x is equal to 8x to the power 3 plus 12x squared minus 40x. And that's it. So we're going to plug in the point x equals to 3. So f dash of 3, that's equal to 8 times 3 cubed plus 12 times of 3 squared minus 40 times of 3. And if you evaluate this, we should get the answer as 204. And that will be our final answer to this question. And this should just be a very simple achieve level question. We see it every year. This is going to be the first question. Very simple, differentiate and plug in a point. Okay, so for question number B, for the function f dash of x equals to 4 minus 6x plus 2x squared, the graph of f of x passes through the point 3 and 4. Find the equation of the function f. So for this question, it's basically just the reverse of what we did for part A. So in this case, we're going to integrate to find the original function. And in order to find the value of our c, our constant, we're going to chuck in the point of 3 and 4. So let's integrate the function. So f of x equals to 4x minus 3x squared plus, so in this case, we're going to add 1 to the power and divide by the new power. So 2 plus 1 is 3, so divide by 3, so 2 over 3x cubed. And don't forget the plus c. Now we're going to plug in the point for 3, 4 in order to find our c value. So we know that 4 equals to 4 times of 3 minus 3 times of 3 squared plus 2 over 3 times of 3 cubed plus c. So that means c will just be equal to 4 minus 12 minus 27 plus 27 and minus 2 over 3 cubed. And that should give us an answer of 1, so c equals to 1. And therefore, f of x is equal to 4x minus 3x squared plus 2 over 3x cubed plus 1. So that should be our answer for this question. And again, this should just be a very simple achieved level question. Okay. Let's move on to question C. So C. Use calculus to find the values of x for which the function f of x equals to 2x to the power 3 divided by 3 plus 3x squared over 2 minus 20x minus 3 is decreasing. So whenever you see like these words decreasing and increasing, these are very key words. So in the case of decreasing, it's just telling you that f dash of x is less than 0. In the case it's increasing, then f dash of x is greater than 0. So in this case, we're just going to be finding all values of the function of f dash of x is less than 0. And in order to do that, we first need to differentiate to find the gradient function. So we're going to just use the power rule again here. So f dash of x equals to 3 times 2 over 3 is 2, so 2x squared plus 2 times 3 over 2 is 3, so plus 3x minus 20. So that's our f dash of x, and we're going to find all of the points where f dash of x is less than 0. So in this case, we're going to be finding 2x squared plus 3x minus 20 is less than 0. And in this case, we're going to notice that for this parabola, in this case, we're going to have this will be a positive parabola, so this will be something like this. Obviously, this is not the exact shape of the parabola, but this will be the rough shape of the parabola. And in terms of the decreasing point, you notice that it's in between the intercepts. So we have the intercepts here and here. So in between the intercepts, we have the function is less than 0. So we'll try to find the intercepts here. So we'll try to factorize this one. So 2x and x. And let's see. Try to find some factors to make this one match up. So we have maybe negative 5 plus 5. Yeah, we have minus 4 plus 4. Plus 4 and minus 5. That should be right. So negative 20 minus 5 plus, yeah, okay, so this equals to 0. So the intercepts are x equals to -4 and x equals to 5/2. And again, like we noticed in the drawing here, that we know that the function is less than 0 in between the intercepts. So therefore, decreasing when x is bigger than -4. Probably do it the other way. Sorry, probably do it. So x is smaller than 5/2, but bigger than -4. Okay, yeah, and that should be a merit level question if you can find the correct interval. So x is between -4 and 2.5 or 5/2. That should be a merit level grade. And if you can find the derivative, so finding the derivative, this step here, that should be an achieved grade there. Okay, perfect. Question D. The tangent of a curve f of x equals to px minus qx squared at the point 2, -10 has a gradient of -6. Find the values of p and q. So for this question, we actually have two equations and two unknown constants. So we have a point, and we have the gradient is -6 at the point x equals to 2. So at x equals to 2, the gradient is -6. So we're going to have two equations here. So we're going to formulate equation 1. So equation 1, we're going to have f of x equals to px minus qx squared, which you're going to plug in the point 2, -10. So -10 is equal to 2p minus 2 squared is 4. 4 times -q is -4q. So -10 equals to 2p minus 4q. That's equation number 1. And we're going to formulate equation 2. And that's going to be using the gradient. So we're going to find the derivative. So f dash of x equals to p minus 2qx. And we're going to plug in the point 2, -6. So -6 is equal to p minus 2 times 2 is 4. So 4 minus p minus 4q. And we're going to solve the simultaneous equation. So we have equation 1. So this is equation 1. We have -10 equals to 2p minus 4q. And we can just subtract these two functions here. So -6 minus -10 is +4. P minus 2p is -p. -4q minus -4q, that's just 0. So that's 0q. So therefore, p equals to -4. And we can plug in p equals to -4 into one of the equations to find the q value. So -6 is equal to -4 minus 4q. So therefore we have -6 plus 4, which is -2, equals to -4q. So q equals to 1/2. And that should be our answer for this question. So we have q equals to 1/2 and p equals to -4. And that should be that's actually an excellence level grade here. So we have an excellence level grade if you can find both solutions for p and q. So both p and q will give you an excellence. If you can find two linear equations, so we have our equation 1 and equation 2. So if you can have both of these equations here, so here and here, that will give you a merit grade. So that's both of them here. If you can find a derivative, so one of the derivatives can be found, then maybe somewhere here, that could be a achieved level grade there. All right, question E. A new business is designing a logo based on a stylized H shape as seen as in diagrams. The logo is designed to be within 2 semicircles and 2 straight lines. The owner of the new business wants to include a space for the name inside the shape, so he has asked the designer to maximize the area inside the shape. The owner plans to build a replica of the logo, and due to material constraints, the total perimeter of the shape must not be greater than 80 centimeters. So we see 3 examples here. So 3 examples of possible shapes are shown below. So we have one with a very small radius, one with a medium radius, and one with a pretty big radius. So we want to find the maximum area. So for these types of questions, I like to start off with just finding out the constraint here. So using the constraint to formulate an equation. So in terms of the perimeter, we know that the circumference is 2 pi r. So actually given that here, so circumference of a circle is 2 pi r. And we have exactly two circles here, two semicircles here, which is just one full circle. So it's going to be exactly 2 pi r for the two semicircles. And we're going to have the two straight lines adding to our perimeter. And we'll call this a new variable. We'll just call this for x. We'll call this side here x. So therefore, the perimeter P is equal to 2 pi r plus 2x. Sorry. It's equal to 2 pi r plus 2x, and in this case the perimeter is equal to the constraint, which is 80, and yeah, we have 2 pi r plus 2x equals to 80, and now we can try to find an expression for the area of the logo. So the area of the logo, we notice, is just going to be the entire rectangle, so we're going to have some area is equal to the rectangle. So when I say rectangle, I just mean this shape here. So that's going to be the rectangle, and that's going to be subtracted from two semicircles. So therefore the area will just be equal to base times height, which is going to be x times of 2r, so 2rx, minus 2 times of the area of the semicircles, which in this case would be one full circle, so that'll just be minus pi r squared. So that's going to be the area, the area expression for the logo. And we have an expression for the perimeter. So we can replace the x here with an expression for r by rearranging the equation for the perimeter. So in this case, we have 80 minus 2 pi r equals to 2x. And therefore, x equals to 40 minus pi r. And we can substitute that into our area formula. So we have area equals to 2r times of 40 minus pi r minus pi r squared. So area equals to 80r minus 2 pi r squared minus pi r squared. Okay, so area equals to 80r minus 3 pi r squared. And now we have the equation, so we're going to differentiate and make equal to 0 in order to find the turning points. In this case, we're trying to find the maximum. So we know that at the maximum point, we know that the gradient function equals to 0. So therefore, we're going to find the derivative with respect to the radius. So dA over dr, or you can just do a dash. dA over dr is 80 minus 6 pi r. And we're going to make equal to 0. So we have 6 pi r equals to 80. So r equals to 80 divided by 6 pi. 80 divided by 6 pi here. So in that case, r is going to be around 4.244. And that's going to be the value for r. So now we're going to substitute back into the area formula in order to find the area. So we have area equals to, area equals to 2 times of 4.244 times of 244, 2 times 4.244 times of 40 minus pi times of 4.244 minus pi times of 4.244 squared. And the area in this case is going to be equal to around approximately 169.8 centimeters cubed. All right, so that's going to be part 1 completed. So that's our area, so 169.8 centimeters squared. And we're going to be showing that this is a maximum. So to show that this is a maximum, we're simply going to find the second derivative, which is we have our dA. So run out of space here. Just very shortly do it here. So we know dA over dr, that was equal to 80 minus 6 pi r. So 80 minus. So therefore, if we find the second derivative, then this will be equal to negative 6 pi, which is strictly less than 0. So that means the second derivative is always less than 0. So therefore, r equals to 2.444 is a maximum. Yeah, and that's all we need for this question. So we need the justification and we need the final area, and that will give us an excellence grade here. So if you can do everything correctly here, that's an excellence. in order to get a merit grade, we need to solve, if we can make a dash equals to 0 and solve for r, that would be a merit. So if you can get up to here, that's a merit. And if you can set up the error equation in terms of a variable and differentiate that variable, then that's an achieved. So getting up to here, that would be an achieved grade there. All right, question 2. The gradient graph of a function y equals to f of x is shown on the axis below, and sketch a possible graph of the original function y equals to f dash of y equals to f of x on the axis below. Okay, so we have the gradient function, and we want to try to find the original function f of x. Alright, so this question, it just says to sketch a possible graph. So this type of language makes me feel like that you don't need to be exact in your exactly like point for point, and coordinates have to exactly match up. But as long as your rough shape and your the shape is correct, then you should be okay. I mean, if you in the exam, if you ever come across these type of questions, as like a side note, if you have time at the end, so let's say you finished all your papers, it's usually really easy to check your answer and to check whether your answer is relatively correct by just using your graphics calculator. This in this example is given really clearly where the intercepts are. So we have -3, -1, and like about 3.5. So you can really easily just find the equation of this graph, which is just, x plus 3, x plus 1 times of x minus 3.5. So that's the equation of this graph. So you can just chuck it into your calculator, just integrate this one, and then make it draw the graph from the graphics calculator. So then you can just see the answer and see whether your drawing matches up. But like I said before, your drawing doesn't really match up exactly with the perfectly match up with the exact answer. Just as long as the shape is correct, you should be okay. So for this question, we just want to start off by noting down all of the intercepts. So we have -3, -1, and 3.5. So at all of these points, we're going to be seeing that the gradient equals to 0. So in other words, all of these points here are going to be turning points. So we're going to be looking at either a maximum, which might look like something like this, so here, or it might be something like here. Sorry, I just drew the same thing twice. My apologies. Okay, or if you're looking at the other way, then it could be a minimum. So something like that. Okay, so just noting down -3 here. So we have -3, -1, and 3.5. Okay, and in terms of whether or not this is a maximum or minimum, so we're going to look at the left-hand side and the right-hand side of these points. So looking on the left-hand side of -3, we see that it's positive, and on the right-hand side, it's negative. So that means the gradient is actually positive, so it's increasing on the left-hand side, but it's decreasing on the left-hand side. So this tells us that at this point here, -3, that is going to be some sort of maximum here. So -3 is a max. So then we can look at the point -1. So on the left-hand side of -1, so for the values less than -1, for a very short distance away from -1, it's less than 0, so it's decreasing. And for small distances above -1, it's increasing. So that tells us that this will be a minimum. So -1 is a minimum. And likewise, if we look at 3.5, it should be alternating. So 3.5, that would be a maximum. Okay, so now that we have so maximum will look like this, minimum that, and maximum should look something like this. And we could also looking at, if you want to make a bit more precise, which I do recommend you do. So in this question, in this particular year, they made this question an excellence level question. So you have to be a little bit more precise here. So if you look at the interval between -3 and -1, and the interval between +1 and +3.5, -1 and +3.5, you see that the decreasing period, or like the decreasing interval, is much smaller than the increasing interval. So what we expect to see here is we're going to be seeing a maximum followed by a small dip and followed by a pretty big increase to the maximum, because of then that's because there's much less of we can call it like much smaller interval in which the graph is decreasing, and there's a much larger interval and where the graph is increasing. And the rate of this increase, if you see this peak here, the rate of this increase is far bigger than that of the decrease. So we expect to see a small increase, small decrease followed by a bigger increase. So now we come down to sketching the graph. So we know that -3 is the maximum. So we might draw something like starting from here, maybe somewhere there. And like I said, between -3 and -1 is a very small decreasing interval. So we might do something small here, and if we can draw this a bit better, so maybe something here. So we get to the minimum at -1, and then there's going to be a bigger increase. We say something like this, maybe up to 3.5, and followed by the decrease. Something like this. And that would probably be somewhere along the lines of our answer, which is a quartic graph. So this is like something x to the power 4, something. And that will be our answer for this question. So something along this line here. So we have the maximums and minimums are correct, and we have the decreasing interval is smaller than the increasing interval. So we have a small dip followed by a much bigger increase. So if you have all of those points covered, including the small dip and the big increase, that's an excellence level grade. In terms of getting a merit level grade, if you have just the correct maximum at -3, minimum at -1, maximum at 3.5, that's a merit level grade. And if you have a negative quartic, it just says a negative quartic. So if you have like a rough shape of like a negative quartic graph, that would be an achieved grade here. Yeah, so for future types of these questions, because I think this is the first year when they made this type of sketching question a excellence level grade, but just keep in mind that any question in NCEA can be an excellence level question. So I suggest you attempt every single question. It's not really worth it to just guess which ones are the excellence level questions and which ones are the merit levels and which ones are the achieved. It's just not worth it. In my opinion, 3 hours is more than enough time for you to complete all of the questions. Since, as an example, this year this was an excellence level question, while in past years it wasn't necessarily so. So just keep that in mind. Cool. Question B. A cricket match is being played. The cricketer hits the ball, and the height h above the grass cricket pitch in meters is modeled by the function, where t is the time in seconds since the ball is hit. We can try to find the maximum height above the ground. So this is again one of those questions where you just find the derivative, make equal to 0, and then substitute back into the original equation. So we have h equals to 22.5 times of t minus 4.9 t squared plus 1. So h dash of t, or dh over dt, equals to 22.5 minus 4.9, 9.8 t. And we're going to make equal to 0. So 9.8 t equals to 22.5. So therefore t equals to 22.5 divided by 9.8. And that's equal to 2.296. And now all we need to do is substitute back into the original equation. So we have h of 2.296 equals to 22.5 times of 2.296 minus 4.9 times of 2.296 squared plus 1. And that should give us an answer of 26.8 meters. And this is a merit level question if you can find the answer. And if you can find the time interval, so the time of 2.296, that is a achieved level grade here. Okay. All right, so during the cricket match, spectators both come and leave the venue. So the number of spectators can be modeled by the following equation. So p equals to 100t squared minus 2 times t to the power 4 plus 750. So p represents the number of spectators in the attendance, and t is the time in hours since it's the start of the match. So we want to show that the rate of change is -258 when t equals to 6. It's a relatively simple question again, so we're just going to find the derivative and then plug in t equals to 6, and we should get an answer of -258. So p dash equals to 200t minus 8t cubed. So therefore p dash of 6 equals to 200 times of 6 minus 8 times of 6 cubed. And that would be, equal to 1200 minus 8 times of, I think 512. No, not too big. Okay, you can just chug into it. I don't have my calculator with me today, unfortunately, but you can just plug that into a calculator. It's 8 times 216. Yeah, okay. And that should be negative 528 as required. And that is this is a multi-part question. Okay, so we're just going to continue. Sorry about that. So what is the meaning of this value for the rate of change? So that just simply means just at the 6th hour that there were that people were leaving at a rate of 528 people per hour. So we're just going to say at the time t equals to 6, the rate of leaving was 528 people at this time. Yeah, leaving was 528 people. That should be enough for that question. And for question part I, so at another match, the number of spectators is modeled by the equation p equals to kt squared minus 2 times of t to the power 4 plus 750. So the number of spectators is growing fastest when t equals to 4. So find the value of k. Okay, so for this question, we do want to be a little bit careful, since when you look at this question at the start, you might think, oh, okay, we just p dash equals to 0 and then find the value of k. But please note the exact wording of this question. So the number of spectators is growing the fastest. So that refers to the rate is the fastest. So that refers to the rate of change of the rate. So it's actually the second derivative which we need to be making equal to 0, not the first. So since the first derivative is when the rate of change is 0, but we want to find the but this is referring to when the rate of change is the fastest. So the fastest rate of the rate, basically, in terms of that. So in this case, we're going to find the second derivative rather than the first. So p dash equals to 2kt minus 8t cubed. So p double dash is equal to 2k minus 24t squared. And we know that p dash equals to 0 when t equals to 4. So 0 equals to 2k minus 24 squared. So therefore, 24 times of 4 squared equals to 2k. So 24 times 16 divided by 2. K equals to 24 times 16 divided by 2. Which in this case is... Okay, so k equals to 12. So k equals to 24 times 8. 192. Okay, so k equals to 192 is our answer here. So k equals to 192. And if you want to just add a little bit of a short explanation, you can just say something like along the lines. So explain your reasoning clearly. You can say second derivative was found equal to 0 since at the fastest rate of growth, since at the time of the, that's probably better, so maybe at the time, the fastest rate of growth, p double dash of t equals to 0. Alright, so those three parts together is a excellence level grade. So if you can find all three of those together, so p double dash equals to 0 and finds k equals to 192, that's an excellence level grade. And if you have a correct interpretation of part 2, so that's part II, that's a merit level grade. And if you can find dp over dt, so that's in any question, so finding dp over dt is an achieved and not only that, so finding dp over dt and also substituting t equals to 6. So that's basically just part I. If you only do part I, you'll probably get an achieved. If you can do part I and part II, you should be able to get a merit. And if you can do this last question here, part III, that should be an excellence level grade there. Okay, cool. Question 3. Find the equation of the tangent of a curve y equals to 2x times x minus 3, where x equals to 1. So this question, probably just to make it a bit more simple, we're just going to expand this expression here. So y equals to 2x squared minus 6x. And to find a tangent, equation of the tangent, we need the plus c value and the gradient value. So y equals to mx plus c, we need the gradient and the intercept. And to find the gradient, we already know what to do. We're going to differentiate and substitute the point x equals to 1. So dy on dx is equal to 4x minus 6. So dy over dx equals to 4 minus 6, which is negative 2. So therefore y equals to negative 2x plus c. And we need to find 1 point in order to find the c value, which you know we are talking about the point x equals to 1. So we're going to find the y value at this point. So y equals to 2 times of 1 times of 1 minus 3. That's equal to negative 4. So therefore negative 4 equals to negative 2 times of 1 plus c. So therefore c equals to negative 2. Okay, so therefore y equals to negative 2x minus 2. And that is a merit level grade if you can find the equation of the tangent, with an achieved if you can find the correct derivative. So derivative here is an achieved. Okay. Okay, the diagrams below show the graphs for the function y equals to f of x, y equals to g of x, and y equals to h of x. So for this question, we're just going to be finding the gradient functions. So for the two linear graphs, the gradient is constant. So what we expect to see is just going to be, we expect to see it's just a straight line through the gradient. So in this case, for y equals to f of x, at the point negative 2, it's 2, and the gradient seems to be exactly negative 1. So if we find negative 1 here, then if I can draw a straight line, maybe, but I'll try my best. So it should look something like that for f dash of x. For g dash of x is going to be positive 1, so it's just going to be exact same thing, but on the positive axis, so maybe somewhere here. So this will just be 1, negative 1. And for y equals to h of x here, where we have a parabola which is decreasing on the left-hand side and increasing on the right-hand side. So it's just going to be increasing. Something like that, since it's decreasing, so it's below the x-axis on the left-hand side, and increasing, which is above the x-axis on the right-hand side. And this is an achieved level grade, and you can get an achieved by just drawing two gradient graphs are correct. That will get you an achieved grade there. Alright, so for question II, the diagram below shows the graph of the function y equals to p of x. On the axis below, sketch the graph of the gradient function y equals to p dash of x. Okay, so for this question, we have the gradient is going to be, again, it's going to be a straight line on the left-hand side and a straight line on the right-hand side. For the left-hand side, we have exactly the same as we had on the previous question. So it's negative 1 on the left and positive 1 on the right. So if we have this here. So that should be our answer for question II. And the open circle just means that the value doesn't exist at the point x equals to 0. So at x equals to 0, the point doesn't exist. So and the reason that it doesn't exist is because at that point, the graph is not differentiable. So the derivative is not defined at that point and that's because of the sharp point here, because we cannot, since the gradient function describes the instantaneous rate of change of the function. It's like the sorry, how to explain this clearly? So if we say the gradient is the rate of change at that instant, at like a specific x point, at that x point, the instantaneous rate of change. But if you notice that x equals 0, it's a complete sharp point, so it goes from the gradient being -1 to the gradient being +1 all of a sudden. So therefore, there's no such instantaneous rate of change of the gradient or the function. There's no instantaneous change of the function. So therefore, the gradient is not defined at that point. So therefore, we cannot differentiate at the point of x equal to 0. And that links perfectly with part I. So is it true to say that the gradient is 0 when x equals to 0? So that's not true, and exactly as we explained above why it's not true. So this is not true. Not true because the graph is not differentiable at the point x equals to 0, and this is because of the sharp point. So the instantaneous rate of change at that, no, I shouldn't say at that point, at x equals to 0, being a bit more precise. So at x equals to 0 is not defined, since the gradient changes from well, it doesn't really need to be change from negative to positive. Just any like sharp point or rapid change, the gradient is not defined. So in this case, something like that should be fine. And this question should be okay. How does this work? Okay, so if you can sketch the graph correctly with the open circles, so with the open circles, it's a merit. If you leave out the open circles, you will get a achieved. So this is actually a merit for part II. For part III, it's actually an excellence level grade. So if you can describe why it's not differentiable at x equals to 0, that would be an excellence level grade. And yeah, and it says description of the issues. Yeah, the assessment schedule says something like just of the issue of drawing a tangent at the sharp point. I think it's better to describe it as like this the instantaneous change of the graph is not really defined, so therefore the graph is not differentiable. So that's excellent there. Cool. Question C. Calculus class is exploring 3D geometrical art. The students decide that they want to create wireframe models of the tetrahedron and octahedron similar to those below. So we have the tetrahedron and octahedron. They will make each edge with a piece of wire and join the pieces together, and then cover each surface with paper to create lanterns similar to those below, which we cannot see, unfortunately. They wish to create a model so that the total resulting surface area of the two shapes is a minimum. Okay. They have a total of 180 centimeters of wire to cut and use for both of the models. Okay, so they give us the expressions for the surface area. So we have square root of 3 times a squared and 2 root 3 times b squared. So therefore, the formula for the surface area that we're trying to minimize is the sum, which is square root of 3 times of a squared plus of 2 root 3 times of b squared times of b. Okay. They have a total of, so the restriction is 180 centimeters of wire. So we need to look at the length of these edges. So if we have 1, 2, 3, 4, 5, 6. Okay, so in this case, I think, so it says A represents the length of each edge of the tetrahedron, and B represents the length of each edge of the octahedron. So in this case, our tetrahedron has different color, sorry. Has 1, 2, 3, 4, 5, 6. So we have 6 edges here. The octahedron has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has 12 edges here. Okay, so in this case, we have our total wire, so expression for the total wire. So 180 is equal to 6a plus 12b. And we can just find a substitute one in for the other. So we see that 6a equals to 180 minus 12b. So therefore, a equals to 30 minus 2b. Okay, cool. Okay, so continue here. So our SA equals to surface area is square root of 3a squared plus 2 root 3b squared. And we just got that a is equal to 30 minus 2b. So therefore, we're going to plug a equals to 30 minus 2b into the surface area function. So SA equals to square root of 3 times of 30 minus 2b squared plus 2 root 3 of b squared. So SA equals to 30 times root. Did something silly. Sorry about that. Sorry. Times 2b whole squared. Okay, let's try that again. Okay, so we have root 3 times of 30 times 30 is 900 plus 4b squared to negative 2b. Negative 2b times 30 is negative 6b times 2 is negative 120b plus 2 root 3b squared. Alright, so we can find the derivative. So SA dash is equal to root 3 times of 8b minus 120 plus of 4 root 3b. And we know that the gradient function equals to 0 at the minimum, so SA dash equals to 0. So therefore, 0 equals to root 3 times 8b minus 120 plus 4 root 3b. And we can just cancel out the root 3's. Okay, so divide both sides by root 3. So 0 equals to 80b minus 120 plus 4b. And therefore, we have 120 equals to 12b. And if we divide both sides by 12, we get b equals to 10. So therefore, b equals to 10 here, and b equals to 10. So what were we trying to find? Sorry, I forgot. So we're trying to find, determine the length of the edges and, determine the length of the edges required and the total surface area. Okay, so b equals to 10, and we know that a equals to 30 minus 2b. So a equals to 30 minus 2 times 10, which is 20. So a is also 10. And we're going to substitute a equals to 10 and b equals to 10 back into the equation for the surface area. So SA equals to root 3 times of 100 plus 2 root 3 times of 100. So that's going to be equal to 3 root 3 times 100. No, it's just 300 and 300 root 3 in this case. Okay, yeah, 300 root 3, that should be, yep, okay. And that's in centimeters squared. Just checking if it's centimeter. Yeah, centimeters squared. And we need to justify if this is a minimum, which is very simple. We're just going to find the second derivative and prove that it's always negative. In this case, positive for the minimum. So SA, that equals to root 3 times of 8 plus 4 root 3. And this is always positive. So because it's always positive, so SA double dash is positive. Therefore, B equals to 10 is a minimum. All right, and that's all we need to do for this question. And this will be an excellence level question if you can find the correct answer with justification. Merit would just be derivative taken and set SA dash to 0. So if we can set SA dash to 0, then we should be able to get a merit level grade here. So that would be which step here? That would be up to here. That's a merit level grade. And to get an achieved, the equation for SA is formed. So we have an SA formed equation. And a substitution is made to eliminate A or B. Okay, so in this case, if we can get up to this step here, that's an achieved. Alright, that's it for this paper, and I hope everything made sense, and I hope that you enjoyed the video, and I hope to see you all in the next one.